What if I told you that the universe, a place so vast, so ancient, and so mysterious, holds secrets that defy everything we think we know about reality? From stars that sing like an orchestra in the silence of space to entire galaxies hidden in plain sight, the cosmos is full of truths so mind-bending they sound more like science fiction than fact. Today, we're embarking on a journey to uncover 20 astonishing revelations about the universe that will challenge your understanding of existence itself. You'll discover why time flows differently near a black hole, how rogue planets drift through the galaxy without a home, and even the eerie possibility that our universe might just be a hologram. And that's just the beginning. Buckle up, because what lies ahead will leave you in awe and make you question everything you thought you knew about the cosmos. Now turning to our first astonishing truth, the universe is expanding faster than we ever imagined. For the longest time, scientists believed that the universe's expansion, set in motion by the Big Bang billions of years ago, should eventually slow down due to gravitational forces. But then, in the late 20th century, something remarkable was discovered. By studying the redshift of light from distant galaxies, a phenomenon where light stretches into longer wavelengths as galaxies move away, astronomers realized that not only is the universe expanding, but this expansion is actually speeding up. The driving force behind it, a mysterious entity known as dark energy, which makes up roughly 70% of the universe. Dark energy is like an invisible hand pushing galaxies apart at an ever-increasing rate. Its implications are profound, leaving us to wonder what this means for the ultimate fate of the cosmos. Will galaxies drift so far apart that the night sky becomes nearly empty in the distant future? Or could the accelerating expansion lead to a dramatic end, tearing everything apart in what scientists call the Big Rip? This discovery has reshaped our understanding of the universe's destiny and revealed just how little we truly know about the forces that govern it. Moving forward, let's explore an awe-inspiring truth about the sheer scale of the cosmos. There are more stars in the universe than grains of sand on all the beaches and deserts of Earth. Imagine scooping up a handful of sand. Each grain is tiny, almost impossible to count. Now multiply that by every beach and desert across the globe. The number you get is astounding, but it still falls short compared to the stars scattered across the universe. Astronomers estimate that the observable universe alone contains roughly 100 billion galaxies, with each galaxy hosting billions or even trillions of stars. That's a number so vast it's nearly impossible to comprehend. To arrive at these mind-boggling figures, researchers study light from distant galaxies using powerful telescopes and advanced models, mapping stars and celestial bodies across the cosmos. This staggering count doesn't even include stars outside the observable universe, hidden beyond the limits of what our current technology can detect. The vastness of space humbles and reminds us of just how tiny our corner of the universe truly is. The next time you look up at the night sky, consider this. Each star you see represents a mere fraction of the cosmic ocean, with countless others shining beyond the reach of our eyes. This perspective makes you wonder, what other secrets does the immense star-filled universe hold? Now turning to one of the most mysterious and fascinating phenomena in the universe, let's talk about black holes and their surprising ability to sing. While space itself is often thought of as silent due to the lack of air to carry sound waves, black holes prove that the universe still has a unique way of making itself heard. Black holes emit what scientists call gravitational waves, which are ripples in space-time caused by massive events like the collision and merging of two black holes. These waves can create vibrations that, when translated by advanced instruments, produce sounds. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, made history by detecting these waves for the first time, capturing the sound of two black holes colliding over 1 billion years ago. The signal, nicknamed the chirp, was a faint, rising tone that gave humanity its first auditory glimpse into the depths of space-time. These cosmic songs are not just eerie and captivating, they also provide groundbreaking insights into the nature of black holes, their masses, and the immense forces at play during these collisions. Through these sounds, researchers are uncovering secrets about the fabric of the universe itself. The concept of black holes singing reminds us that even in the vast silence of space, there are whispers of the incredible forces shaping our cosmos. Could these tones and vibrations hold even more clues about the workings of the universe? The journey of discovery continues. Moving forward, let's dive into one of the biggest questions in cosmology. Could the universe truly be infinite? Scientists have long debated whether the cosmos has a definitive edge or whether it stretches on eternally. What we refer to as the observable universe is the region we can see and study about 93 billion light-years in diameter, limited by the speed of light and the age of the universe. Beyond this, however, lies the great unknown. Some theories suggest that the universe might loop back on itself, forming a kind of cosmic sphere, while others propose it could extend infinitely with no boundaries whatsoever. The idea of an infinite universe is mind-boggling. If space goes on forever, it could mean there are regions so far away that their light hasn't had enough time to reach us, effectively hiding untold secrets. Recent measurements of the cosmic microwave background radiation, the faint afterglow of the Big Bang, hint at an ever-expanding universe, but they don't conclusively answer whether it's infinite or finite. Even more intriguing, some researchers speculate that what we see might only be one part of a much larger multiverse, a collection of countless universes, each with their own unique properties. If the universe is infinite or part of a multiverse, then the possibilities for what exists are beyond anything we can currently imagine. As we peer deeper into the cosmos, this eternal mystery serves as a humbling reminder of just how small we are in the grand design of the universe. Now turning to a truly perplexing feature of our universe, let's discuss the enigmatic cold spot in the cosmic microwave background radiation. This faint glow is essentially the afterglow of the Big Bang, a snapshot of the universe as it was nearly 14 billion years ago. However, scientists have discovered an unusual region that defies the norm, a vast area significantly colder than the surrounding cosmic radiation. This cold spot spans roughly 1 billion light-years and has left astronomers scratching their heads since its discovery. One theory suggests it could be the result of a supervoid, an immense region of space with far fewer galaxies and matter than usual. If this is the case, the supervoid could cause light traveling through it to lose energy, creating the cold appearance we observe. But here's where it gets even more fascinating. Some researchers propose that the cold spot might be evidence of something entirely different. They speculate it could be a vestige of an interaction between our universe and another, hinting at the existence of a multiverse. If true, this would be one of the most groundbreaking discoveries in cosmology, reshaping our understanding of reality itself. While we don't yet have definitive answers, ongoing studies and future observations may reveal more about this chilling cosmic mystery. The possibilities it opens up, whether they link to unseen parts of our universe or entirely separate realities, are as thrilling as they are mysterious. Moving forward, the cold spot serves as a stark reminder of how much we still have to learn about the hidden intricacies of the cosmos. Moving forward, let's unravel one of the greatest enigmas in astrophysics, the dark matter puzzle. Imagine a substance that makes up about 85% of all the matter in our universe, yet it remains completely invisible to us. This is dark matter, a mysterious form of matter that neither emits nor absorbs light, making it undetectable through conventional means like telescopes or other instruments. So how do we know it exists? Scientists have uncovered its presence through its gravitational effects. For instance, when observing galaxies, astronomers noticed something peculiar. the outer stars in galaxies seem to orbit their galactic centers at the same speed as those closer to the core, defying what we'd expect based on visible matter alone. This unexpected phenomenon can only be explained if there's an unseen mass enveloping these galaxies, exerting gravitational pull dark matter. Another compelling clue comes from gravitational lensing. This is when light from a distant galaxy or star gets bent as it passes near a massive object like a galaxy cluster due to its gravitational field. The degree of bending often far exceeds what could be caused by the visible matter alone, pointing once again to the hidden mass of dark matter. But what exactly is dark matter? That's the million-dollar question. Some theories suggest it could be made up of yet undiscovered particles, while others propose more exotic possibilities. Despite decades of research, its true nature remains elusive, pushing scientists to develop highly sensitive detectors and conduct experiments deep underground or even in space. Each piece of evidence brings us a step closer to solving this cosmic mystery, and with advances in technology, we might soon uncover what this invisible substance really is. For now, dark matter continues to challenge everything we know about the composition and behavior of the universe, a shadowy reminder of how much is still waiting to be understood. Now turning to a theory that might just reshape your perception of existence itself, let's delve into the holographic universe theory. Imagine for a moment that everything you see, touch, and experience, every galaxy, star, and particle, is not as it appears, but rather a three-dimensional projection from a two-dimensional surface. This is the essence of the holographic universe theory, a groundbreaking concept that suggests the entire universe could function much like a hologram. But what does this actually mean? Essentially, this theory posits that all the information that makes up our seemingly three-dimensional reality is stored on a flat, two-dimensional boundary. To put it simply, it's as if our universe is like a television screen, and what we perceive as depth is just an illusion. This mind-bending idea finds its roots in the study of black holes. Researchers have observed that when matter falls into a black hole, the information about that matter doesn't disappear entirely, but might instead be encoded on the black hole's surface. This discovery led scientists to wonder if the universe itself could operate on a similar principle. One piece of evidence supporting this theory comes from the mathematical findings of string theory, which suggests that such a holographic model could help reconcile the seemingly incompatible theories of quantum mechanics and general relativity. However, as intriguing as this idea is, it remains highly speculative. Critics argue that while the mathematics is compelling, there's no direct observational evidence yet to confirm the holographic nature of the universe. Nevertheless, this theory sparks profound questions about the very fabric of reality, challenging us to consider that what we perceive as tangible and real might be an elaborate projection. So, is our universe truly a cosmic hologram, or is it something even stranger? Only time and further exploration will tell, but for now, the holographic universe theory stands as one of the most fascinating and thought-provoking ideas in modern science. Moving forward, let's uncover the eerie phenomenon of rogue planets, worlds that drift aimlessly through the galaxy, untethered to any star. Unlike the planets in our solar system, which orbit the sun in a predictable dance, rogue planets have been ejected from their home star systems, left to wander the vast cosmic void. This can happen due to gravitational interactions with other massive objects or violent events within their original systems. But how do we even detect these elusive, starless planets amidst the darkness of space? Without a nearby star to illuminate them, scientists rely on techniques like gravitational microlensing. This method involves observing the subtle bending of light from distant stars caused by the gravity of a rogue planet passing in front. It's an extraordinary process that requires incredible precision, but it has allowed us to identify over a dozen rogue planets so far. And what might these lonely travelers look like? Picture a world shrouded in perpetual night, its surface perhaps frozen or cloaked in dense clouds, with only the faint glow of internal heat offering any light. Some might even harbor subsurface oceans kept warm by geothermal activity, sparking speculation about the possibility of life in such extreme environments. These wandering planets remind us of the unpredictable and chaotic nature of the universe, where even something as seemingly constant as a planet's orbit can be disrupted. They challenge our understanding of planetary formation and survival, revealing a side of the cosmos that is as mysterious as it is fascinating. So, as we delve deeper into the mysteries of space, rogue planets stand as a poignant reminder of just how little we truly know about the vastness beyond. Now turning to the astonishing concept of dark galaxies, we venture into a realm of the universe that is nearly invisible to us. Unlike conventional galaxies filled with billions of shining stars, dark galaxies are composed predominantly of dark matter, with little to no star formation. This means they emit almost no light, making them undetectable through traditional methods like telescopes. So, how do scientists even know these shadowy galaxies exist? The answer lies in gravitational effects. Dark matter, though invisible, interacts with surrounding objects through its immense gravity. By studying the behavior of nearby stars and galaxies, as well as the bending of light from distant sources in a phenomenon called gravitational lensing, scientists have inferred the presence of these enigmatic structures. Imagine observing a region of space that appears empty, only to discover through its gravitational impact that it is teeming with hidden matter. Simulations and advanced models suggest that these galaxies might look like vast, diffuse clouds of dark matter, devoid of the brilliant lights we often associate with galaxies. Though they remain one of the biggest puzzles in astrophysics, dark galaxies offer a fascinating opportunity to learn more about the elusive dark matter, which is believed to make up most of the universe's mass. They challenge the very definition of a galaxy and push us to rethink what constitutes these colossal structures in the cosmos. As we piece together the mystery of dark galaxies, they serve as a testament to how much of our universe remains cloaked in secrecy, waiting to be discovered. Moving forward, let's unravel the misconception that space is completely silent. While it's true that the vast majority of space is a vacuum where sound waves cannot travel due to the lack of particles, there are certain regions in the cosmos where sound does exist. Dense clusters of gas and dust, such as nebulae, provide enough particles for sound waves to move through. These sounds, however, are not like what we hear on Earth. Instead, they are vibrations and frequencies that require specialized instruments to detect and translate into audible formats. For example, scientists have captured the eerie hums of waves inside gas clouds or the vibrations within planetary atmospheres. Even more fascinating, NASA has transformed data from space into sound, offering eerie and otherworldly acoustic landscapes. These recordings give us a glimpse into the hidden symphony of the universe, from the haunting echoes of black holes to the rhythmic pulses of distant stars. It's a reminder that the cosmos, while vast and mysterious, carries its own kind of music, waiting for us to listen. And as these discoveries unfold, they challenge our understanding of what silence means in the boundless expanse of space. Now turning to a truly mind-bending fact about our neighboring planet, Venus. Did you know that a single day on Venus is longer than an entire year? That's right, Venus takes about 243 Earth days to complete just one rotation on its axis, while its orbit around the Sun only takes 225 Earth days. But that's not all. Venus also spins in the opposite direction to most planets in our solar system, a phenomenon known as retrograde rotation. This means that if you were standing on Venus, you would see the Sun rise in the west and set in the east, though it would take an astonishingly long time to happen. Scientists believe this peculiar rotation could be the result of massive collisions during Venus's early formation, or the gravitational effects of the Sun over billions of years. Whatever the cause, Venus continues to defy our expectations, making it one of the most intriguing planets to study. Its slow spin and backward motion are just a few of the many mysteries that remind us how diverse and fascinating our solar system truly is. Moving forward to one of the densest and most extreme objects in the universe, neutron stars. Imagine this, an object so compact that just a sugar cube-sized piece of it would weigh billions of tons. That's the unimaginable density of a neutron star. These celestial wonders are born from the explosive deaths of massive stars known as supernova. When such a star exhausts its nuclear fuel, its core collapses under gravity, crushing protons and electrons together to form neutrons. What remains is a neutron star, often no wider than 20 kilometers but packing more mass than our Sun. To put this into perspective, if you could somehow bring a small teaspoon of neutron star material to Earth, it would weigh as much as an entire mountain. The immense gravity of these stars creates a surface where the escape velocity is nearly half the speed of light. This extreme environment also makes neutron stars powerful sources of radiation, emitting beams of energy that can be detected as pulsars if they are oriented toward Earth. These cosmic marvels aren't just dense, they serve as natural laboratories for the study of physics under conditions that can't be replicated anywhere else. Neutron stars are like time capsules, offering glimpses into some of the most violent and transformative events in our universe, while challenging the very limits of human understanding. Now turning to an enigmatic force that is subtly but persistently reshaping the cosmic landscape, the Great Attractor. Hidden deep within the Laniakea supercluster, a massive web of galaxies to which our own Milky Way belongs, lies this gravitational anomaly that has baffled scientists for decades. The Great Attractor exerts an immense gravitational pull, drawing entire galaxies, including our own, toward it at astonishing speeds of over 2 million kilometers per hour. To put this into perspective, imagine a cosmic river where galaxies are carried not by water but by the invisible currents of gravity. What makes the Great Attractor so mysterious is that we cannot see it directly. Its location is obscured by the thick clouds of stars and gas in the plane of the Milky Way, a region known as the zone of avoidance. However, its gravitational influence is undeniable, as it distorts the movements of galaxies across vast cosmic distances. So, what could it be? Some theories suggest it might be a colossal collection of galaxies, clusters, and dark matter, all weighing the equivalent of millions of Milky Ways. Others propose even more exotic explanations, like a massive supercluster or structures beyond the observable universe. The nature of the Great Attractor is still an open question, one that challenges our understanding of cosmic forces and the distribution of matter in the universe. As researchers develop more advanced tools to peer through the obscuring veil of the Milky Way, every new discovery brings us a step closer to uncovering the truth behind this gravitational enigma. With mysteries like this, it becomes clear just how little we truly know about the forces that shape the cosmos. Moving forward, let us journey into the realm of ancient starlight, where the light we see today tells stories from a time long before Earth even existed. The concept is simple yet utterly profound. Light from distant stars and galaxies takes an incredible amount of time to reach us, because light travels at a finite speed, about 300,000 kilometers per second. What we are witnessing when we gaze at these celestial objects is essentially a snapshot of the past. For example, if a galaxy is located over 13 billion light-years away, the light we see today began its journey billions of years ago, possibly only a few 100 million years after the universe itself was born. This means that every twinkle of light we observe is not just a star or galaxy but a time machine, a portal to an era when planets like Earth were not even a thought in cosmic history. The age of this light reveals an astonishing truth about the vastness of the cosmos and how we are intrinsically connected to its endless timeline. Scientists use extraordinary tools like the Hubble Space Telescope and the James Webb Space Telescope to capture this ancient light, offering us glimpses of the universe's early days through breathtaking images of distant galaxies. These telescopes are not just lenses into space but windows into time, unraveling the evolution of the cosmos layer by layer. So, as you look up at the night sky, remember that you are seeing not just stars but ancient whispers of a universe that has continually evolved over billions of years. What other secrets might these celestial time capsules hold? With the next phase of the journey in sight, let us unravel one of the most fascinating and mind-bending truths about our universe. Time does not move at a constant rate everywhere. This phenomenon, called time dilation, is at the heart of Einstein's theory of relativity. Imagine two clocks, one on Earth and another placed near a massive celestial object like a black hole. The clock closer to the black hole ticks more slowly compared to the one on Earth. This happens because massive objects like black holes create an intense gravitational field that warps both space and time. As bizarre as it sounds, this stretching of time has been proven through multiple experiments and even plays a role in our daily lives. Consider GPS satellites orbiting Earth. These satellites are far enough from Earth's gravitational pull that time moves slightly faster for them compared to clocks on the surface. Without constantly accounting for this difference, GPS technology would quickly become inaccurate, with errors piling up by several kilometers each day. In the realm of science fiction, time dilation opens up thrilling possibilities. For instance, astronauts traveling near the speed of light or venturing close to a black hole would experience time much more slowly than those back on Earth. To the traveler, a few hours or days might pass, while years or even centuries could unfold for those they left behind. This concept is more than theoretical. It has been observed in particle accelerators, where particles traveling near light speed decay more slowly compared to those at rest. These experiments and examples demonstrate the profound influence of gravity and speed on time itself, reshaping our understanding of the cosmos and our place within it. So, the next time you glance at your watch, consider how differently that same moment might unfold near a black hole or aboard a spacecraft hurtling through space. What other cosmic phenomena could transform something as seemingly fundamental as time itself? As the next chapter of our exploration begins, we arrive at one of the most mysterious and baffling regions in the cosmos, the Boötes void. Imagine a vast expanse of space so empty that it defies comprehension. This region, often referred to as a supervoid, spans an astonishing 330 million light-years across. To put this in perspective, if you were to line up galaxies like beads on a string within this void, you would find only a handful scattered across an area where thousands would usually be expected. So, why is the Boötes void so empty? Scientists have posed several theories to explain this cosmic anomaly. One idea suggests that it could be a natural result of the universe's evolution, where regions with fewer galaxies simply became emptier over time as gravitational forces pulled matter toward denser areas. Another, more speculative theory hints at the possibility of interactions with other universes, where the Boötes void might be a region left affected by such encounters. While these ideas remain unproven, they highlight just how much we still have to learn about the nature of our universe. Studying the Boötes void not only deepens our understanding of galaxy formation and distribution, but also challenges our perceptions of what exists or does not exist in the vast stretches of space. The next time you gaze at the night sky, remember that among the countless stars you see, there are also immense empty voids like Boötes, silently holding their secrets, waiting to be uncovered. What other hidden wonders might be lurking in the dark tapestry of the cosmos? Now turning to one of the most fascinating and eerie phenomena in the universe, let us explore the concept of vampire stars. Picture a binary star system where two stars are gravitationally bound and locked in an intricate dance around one another. In some of these systems, one star becomes a cosmic vampire, siphoning mass and energy from its companion. This happens when the gravitational pull of the more dominant star becomes so intense that it begins to strip away the outer layers of its companion. The material is drawn towards the vampire star, forming a swirling disk of gas and dust as it spirals in. Over time, this process can significantly alter the mass and size of both stars. The vampire star increases in mass, often becoming brighter and hotter, while its companion loses material and becomes stripped down to its core. This dramatic interaction not only affects the immediate life cycles of the stars, but can also lead to explosive endings like supernova or even the formation of neutron stars or black holes. These systems reveal just how dynamic and violent the universe can be, where even stars are not immune to predatory behavior. It is a haunting reminder of the constant struggle for survival that plays out on every scale of the cosmos. Could there be other unknown consequences of such stellar vampirism lurking in the shadows of the universe? Moving forward, the universe takes us to a hauntingly silent era known as the Cosmic Dark Age. Imagine the universe shortly after the Big Bang, filled with a searing sea of particles cooling and expanding, yet devoid of any light-emitting objects. This was a time before the formation of stars and galaxies, when the cosmos was a vast, dark expanse with no points of brightness to pierce the void. During this period, the universe consisted mostly of hydrogen and helium atoms, quietly awaiting the spark that would ignite the first sources of light. But how do scientists uncover truths about a time so distant and dark? The answer lies in the cosmic microwave background, often described as the faint afterglow of the Big Bang. This radiation, still detectable today, acts as a time capsule carrying clues about the conditions of the early universe. By studying subtle temperature fluctuations in the cosmic microwave background, researchers can map the distribution of matter and better understand how the first cosmic structures began to form. This dark age serves as a crucial chapter in the story of the universe, where silence and shadow set the stage for the dazzling drama of stars and galaxies to come. How did the darkness end, and what sparked the first glimmers of light in this primordial void? That is a story of its own, one that reveals the universe's relentless march towards complexity and illumination. With the next phase of the journey in sight, we arrive at the enigmatic frontier of our solar system, the Oort cloud. Imagine a distant spherical shell of icy bodies, stretching far beyond the orbit of Neptune, surrounding our solar system like a ghostly halo. This theoretical region is believed to be a reservoir for long-period comets, those icy travelers that occasionally streak through our skies with brilliant tails, only to vanish for thousands of years. But why is the Oort cloud such a mystery? For one, it's incredibly far away, likely beginning hundreds of billions of miles from the Sun, a distance so vast that even our most advanced telescopes struggle to detect anything directly. Instead, scientists infer its existence based on the behavior of comets whose orbits suggest they were dislodged from this deep freeze by gravitational nudges, possibly from passing stars or galactic tides. Despite its elusiveness, the Oort cloud holds profound significance. It serves as a time capsule from the early days of our solar system, preserving icy fragments that could reveal the building blocks of planets and even clues about the origins of life. And yet, we've barely begun to unravel its secrets. Could it be more dynamic than we imagine, or does it hide surprises about the forces shaping our solar system? This frozen boundary challenges us to reach beyond what we know, reminding us that even our cosmic backyard holds mysteries as vast as the stars themselves. Moving forward, let us delve into one of the most dramatic and awe-inspiring phenomena in the cosmos, the tidal disruption events. Imagine a star, much like our Sun, wandering too close to a monstrous black hole. As it approaches, the immense gravitational forces of the black hole begin to tear the star apart in a process known as spaghettification. This violent event occurs because the gravitational pull on the side of the star closest to the black hole is far stronger than on the far side, stretching the star into an elongated stream of stellar material. Eventually, this stream spirals around the black hole, forming an accretion disk, a swirling, luminous ring of gas and debris. This process releases a massive amount of energy, often shining brighter than an entire galaxy for a short period of time. One of the most well-documented tidal disruption events occurred in a galaxy over 200 million light-years away, where telescopes captured the brilliant flare of a star being shredded by a black hole nearly 1,000,000 times the mass of our Sun. These events are more than just cosmic fireworks. They offer a unique opportunity for scientists to study the extreme physics near black holes and understand more about their feeding habits. By observing these dramatic encounters, we gain valuable insights into the life cycle of stars and the role black holes play in shaping their surrounding galaxies. In the grand theater of the universe, tidal disruption events remind us of both the incredible power of black holes and the delicate balance of cosmic forces at play in the dance of stars. With the next phase of the journey in sight, let us expand on the fiery aftermath of a star's dramatic end as it meets its demise near a black hole. The shredded material from the star does not simply disappear. Instead, it begins an extraordinary and chaotic descent into the black hole's grasp. This spiraling matter forms what is known as an accretion disk, a glowing ring of superheated gas and dust that orbits the black hole. As the material accelerates and collides within the disk, it reaches temperatures of millions of degrees, unleashing immense radiation that can be observed across vast cosmic distances. These flares of light often outshine entire galaxies, providing astronomers with a brief yet spectacular window into the otherwise dark and enigmatic behavior of black holes. Recent observations, supported by sophisticated simulations, have revealed fascinating details about these events. For instance, scientists have detected bursts of X-rays and ultraviolet light, signatures of the violent energy release as the star's remnants are consumed. These findings not only help us track the feeding patterns of black holes, but also shed light on the dynamics of extreme gravitational environments. By studying these incredible pyrotechnics, we gain deeper insight into the interplay of matter and energy in some of the most extreme conditions in the universe. It is a reminder of how stars, even in their destruction, contribute to the ongoing story of cosmic evolution. With the next phase of the journey in sight, let us revisit the awe-inspiring concept of the universe's expansion, a phenomenon that has puzzled and fascinated scientists for decades. The discovery that the universe is not only expanding but doing so at an accelerating rate was made possible through a remarkable observation known as redshift. When light from distant galaxies stretches as these galaxies move away from us, it shifts towards the red end of the spectrum. This subtle change in light serves as a cosmic clue, revealing the rate at which the universe grows. Instruments like the Hubble Space Telescope have played a crucial role in mapping this expansion, capturing images of far-off galaxies and measuring their distances with extraordinary precision. But perhaps the most groundbreaking discoveries are now emerging from the James Webb Space Telescope. Its advanced capabilities allow us to peer even further back in time, capturing light from galaxies that formed shortly after the Big Bang. This telescope has not only confirmed the accelerating expansion, but has unveiled previously hidden details about galaxy clusters and the distribution of matter across vast cosmic scales. By analyzing this data, scientists can refine our understanding of dark energy, the mysterious force thought to drive this acceleration. These findings are not just numbers and measurements, they are snapshots of the universe's past, present, and future. They help us piece together the story of how galaxies evolved, how cosmic structures formed, and perhaps even hint at the ultimate fate of the cosmos. The realization that the universe continues to expand faster than we once imagined underscores a profound truth. the more we learn about space, the more it humbles us with its complexity and boundless mysteries. Moving forward, let us delve into one of the most perplexing mysteries of modern astrophysics, the distinction between dark matter and dark energy, two enigmatic forces that dominate the universe yet remain invisible to the eye. Dark matter, though unseen, is a crucial glue holding galaxies together. Its presence can be inferred through its gravitational effects, such as the way stars at the edges of galaxies rotate much faster than expected. This behavior defies the predictions we would make based on visible matter alone, signaling the presence of an unseen mass dark matter. On the other hand, dark energy is an entirely different kind of mystery, acting as a repulsive force that accelerates the universe's expansion, counteracting gravity's pull. While dark matter binds cosmic structures, dark energy pushes them apart. Theories about their interaction suggest that these forces may be two sides of the same cosmic coin, intricately linked in ways we are just beginning to theorize. Scientists are devising ingenious experiments to uncover the essence of these phenomena, from mapping cosmic microwave background radiation to studying gravitational lensing, where light from distant galaxies bends around massive objects. These efforts allow us to visualize the otherwise unseeable, revealing intricate maps of where dark matter is concentrated. Meanwhile, experiments like observing Type 1, a supernova, have been pivotal in understanding dark energy's influence. As research advances, simulations of the universe provide glimpses of how these forces operate on the grandest scales, showcasing a cosmic dance where matter and energy intermingle to shape everything we observe. The quest to understand dark matter and dark energy is not just about solving a cosmic puzzle. It is about unlocking the fundamental principles that govern the universe itself, challenging us to rethink what we know about reality and driving humanity ever closer to answers that may one day transform our place in the cosmos. Now turning to the elusive realm of dark galaxies, we uncover a fascinating chapter in the quest to understand the cosmos. Unlike the vibrant galaxies filled with gleaming stars, dark galaxies are cloaked in invisibility, composed almost entirely of dark matter with little to no star formation. These enigmatic structures do not emit or reflect light in ways that make them detectable through traditional telescopes. So, how do scientists even know they exist? The answer lies in their gravitational influence on their surroundings. By observing how light from distant objects bends, a phenomenon known as gravitational lensing, researchers can infer the presence of these hidden galaxies. This bending of light acts like a cosmic fingerprint, revealing the mass concentrations where these dark galaxies reside. But the study of dark galaxies does not stop there. Scientists are also examining how they interact with visible matter, such as by analyzing the movements of nearby stars and gas clouds. For example, the slight tug of gravity from a dark galaxy can alter the motion of objects around it, providing clues about its size, shape, and distribution. Advanced simulations of the cosmos allow researchers to recreate these interactions on a grand scale, offering insights into how dark galaxies might influence the formation and growth of larger galaxy clusters over billions of years. The search for dark galaxies is not just about cataloging unseen objects. It is fundamentally reshaping our understanding of the universe. These mysterious formations could hold the key to unlocking the secrets of dark matter itself, offering a glimpse into the invisible framework that holds the cosmos together. Each discovery pushes the boundaries of what we know, challenging our assumptions and opening doors to new theories about galaxy formation and evolution. As we refine our tools and techniques, the unveiling of these hidden giants could rewrite the narrative of how the universe came to be and where it is heading. Moving forward, let us explore one of the most intriguing implications of Einstein's theory of relativity time travel. At its core, the concept of time travel is rooted in the phenomenon of time dilation, a strange yet proven effect that occurs under two extreme conditions, near massively dense objects like black holes or during incredibly high speed travel nearing the speed of light. Time dilation means that time itself does not flow at a constant rate for everyone. For instance, someone traveling at near light speeds or orbiting close to a black hole would experience time much more slowly compared to someone far away from such phenomena. This means that seconds for one could translate to years for another, effectively creating a form of time travel into the future. But how could this work in practice? Consider this: if an astronaut were to journey on a spacecraft traveling at speeds approaching the speed of light, they might age only a few years, while decades or even centuries pass for those left behind on Earth. This is not just theoretical, it has been observed in experiments using atomic clocks on high-speed planes and satellites, where clocks moving faster actually ticked slower compared to stationary ones. The effect, while tiny at these speeds, becomes drastic as we approach the cosmic extremes described by relativity. Yet, time travel does not stop at science fiction-like journeys into the future. Scientists have also speculated about what it might take to journey into the past, though this remains far more contested. Theoretical models, such as wormholes, propose shortcuts through space-time that could theoretically connect distant points in time as well as space. However, these concepts are riddled with challenges, including the need for materials with exotic properties that may not even exist. Despite these hurdles, experiments in quantum physics and advances in understanding the fabric of the universe push the boundaries of our knowledge, inching us closer to unlocking these mysteries. Ultimately, the possibility of time travel, whether into the future or the past, continues to ignite debate and imagination. It challenges the very nature of our reality and our place within it. As scientists refine their understanding of relativity and explore new frontiers, the dream of traversing time may one day leap from the realm of theory to reality. For now, it remains one of the most fascinating questions in our quest to understand the universe, bridging the gap between the known and the possible. And with that, we step further into the cosmos, where mysteries like these are just waiting to be uncovered. Now turning to the cosmic dark age, a time that represents one of the most enigmatic chapters in the history of our universe. Shortly after the Big Bang, the universe was a sea of darkness, no stars, no galaxies, just a vast expanse of neutral hydrogen and helium stretching endlessly. This period, known as the Cosmic Dark Age, lasted for hundreds of millions of years until an extraordinary transformation began. Scattered throughout this darkness, the first stars, known as population 3 stars, ignited and brought an end to this cosmic void. These stars were unlike any that we see today. They were massive, burning at temperatures and intensities far greater than the stars we are familiar with. Made almost entirely of hydrogen and helium, these early stars lacked the heavier elements that today's stars incorporate. This absence of metals made them burn quickly and live short, explosive lives, often ending in dramatic supernova. But it was these violent deaths that laid the foundation for the cosmos as we know it. When these stars exploded, they forged and scattered the very elements necessary for life: carbon, oxygen, iron, seeding the universe with the building blocks for future stars, planets, and eventually life itself. As more of these stars formed, their intense radiation began to reionize the neutral hydrogen surrounding them, illuminating the universe and allowing light to travel freely for the first time. This monumental event, referred to as the Epoch of Reionization, marked the end of the Cosmic Dark Age and set the stage for the formation of galaxies. Proto-galaxies, clusters of these early stars, began to take shape, laying the groundwork for the intricate structures of the cosmos we see today. These early moments of light not only transformed the universe, but also hold the answers to many questions about how we came to exist. Modern telescopes like the James Webb Space Telescope are designed to peer back into this ancient light, offering a glimpse into these first moments of creation. Understanding these early stars and their role in reionization continues to be a key goal for scientists, as it bridges the gap between the darkness of the early universe and the luminous galaxies we see today. With this understanding, a clearer picture of our cosmic origins unfolds, one where the first sparks of light revealed the vast potential of the universe that was yet to come. As we conclude our journey through these 20 astonishing truths about the universe, one thing becomes abundantly clear: the cosmos is far more mysterious, vast, and wondrous than we could ever have imagined. From the mind-bending idea of an infinite universe to the eerie silence of dark galaxies and the violent beauty of stars being torn apart by black holes, each fact challenges what we think we know and pushes the boundaries of human understanding. These revelations remind us that the universe is a place of endless discovery, where every answer sparks new questions. It is a realm where the smallest particles and the largest cosmic structures are intertwined in a dance of creation and destruction, shaping the story of existence itself. So, which of these truths left you in awe? Let us know in the comments below. And if you want to continue unraveling the mysteries of space with us, do not forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an upload. The universe is calling, and the adventure to understand it has only just begun.